Hey guys, welcome back to another new video. So in this video we will learn about what is exception handling in Python. When we write our program, it is very important for us to use the concept of exception handling so that we can run our program very smoothly and effectively. It may not be needed for small programs like which we use to practice our coding, but when we try to write very complex programs, in that particular programs it is very essential for us to use the exception handling concept to make our code very smooth and easier to understand. So without any delay, let's learn what is exception handling. So firstly, what are exceptions? Exceptions are events detected during our program execution. Like when we try to execute our program, there would be some kind of errors which occur dynamically without any syntax errors. Those type of errors are called as exceptions, which are not in our hand to control, but they signal a problem that requires immediate attention. Like we need to give a particular solution to that kind of error so that the exception will not be raised and our code will run smoothly. So exceptions can be also defined as the errors that are detected during execution. So it indicate a problem to address. For example, we have many kind of errors which are default, like type error, value error, index error, etc. So if we do not handle the exceptions, the program may crash and our code may not be worked properly. So why to handle exceptions? As I have previously mentioned, the program will be crashed if we do not handle exceptions immediately. So graceful recovery, it allows the program to recover from errors. Like if we use the exception handlings perfectly without any mistake, the recovery will be very smooth and fast, and it is also very efficient for the program to make it run successfully. So in the exception handling concept, we have mainly two blocks like try block and except block. Firstly, let us see what is try block. The try block, it encloses the code that might raise an exception, like it is the primary code. Like we write the code which we want to execute, that must be written in the try block. But if we may have doubt that it may raise some kind of error which we do not know, so that type of code is written in try block. It may raise error or may not raise an error. So the except block specifies how to handle specific kind of exceptions. Like if we have a kind of imagination or a feeling that our primary code must will raise an error, so for that kind of errors we need to write the statement or solution in the except block so that the user will get to know what is the kind of error it is getting, or and how can we resolve it. So the except block is executed only if the try block raises an error. If the try block does not raise an error and the whole code which is in the try block executes perfectly, then the cursor or the program does not go into the except block and does not execute anything which is present in the except block. Here the simple example is given. So here first we will write the try block. In try block we have written the result is equal to 10 divided by 0. We know that any number divided by 0 does not give any result. It means it is invalid. We know that it will raise definitely an error. So for that kind of error we are writing an except block. So here this is a zero division error. Like as I have mentioned earlier, there are a few default errors. So here in this case it is a zero division error. So for that error we are writing the print statement as cannot divide by 0. So by seeing this we can understand that any number cannot be divided by 0, and hence we can make required changes in our primary code so that it will not raise this kind of error. So we also have a feature like we can use multiple except blocks. It is not mandatory that we need to use only one except block for one try block. We can use many number of except blocks for one try block. If one except block is not related to that kind of try block or that kind of error, another except block will be checked until all the except blocks are covered. If in middle any particular except block is satisfying the kind of error that is raised in the try block, the remaining except blocks will be skipped. So here as you can see there is another example. Here first we have a try block in which it is written as integer of abc. Like we know that a string cannot be converted into an integer, right? So it may raise the value error. Like abc cannot be converted into an integer, so it is not a perfect value. So here we also have another statement like result is equal to 10 divided by 0. We have already discussed that it is a zero division error. So here we need to write the except block, like except value error. Here in value error is one of the default errors which we use to check eh, if the input or the statement is a value or it is a string or not. If it is not a perfect value, then it raises the value error. Here we have the print statement as invalid input for integer conversion. Like we know that string cannot be converted into an integer, so this except block satisfies the first statement. In second except block we have zero division error, which automatically satisfies the second statement as we have discussed earlier. So in this way we can use the try and except blocks, and we can use the exception handling concept. So raising errors with raise, as I have already mentioned earlier, there are few default errors which are present in Python, which we can access automatically by writing the error name. But there might be few types of errors which are not default and not mentioned in Python, but we can raise errors, or we can write the except block statements by raising an error. Like this kind of error may be raised during running our primary code. For that we can raise our errors by using the raise statement or raise keyword. So these type of errors are called as custom errors. Like we are defining, the user is defining the errors. These type of errors are called as raise errors. So we will not go very deep into this raising errors. We just try to understand how to handle the exception using try block and except block. Guys, as we have discussed, exceptions are critical for robust Python applications. So using try blocks in Python applications, using exception handling concept in Python applications is very mandatory, and it is very useful for us to detect different kind of bugs and errors, and we can solve them automatically within very less span of time. So to recover errors, try and except block is very useful, and it is very graceful also. Raise custom errors for precise control. Like if we have any feeling of raising any new error, like it may give any new error, we need to use the raise errors. So these are few advantages of using the exception handling concept. So now let us try to understand it with an example. As we are now on our code editor screen, now let's try to understand the concept of exception handling with a simple example. So in this program we will try to take two integer inputs from the user, and let's try to divide them. So first, for writing our primary code, we need to create a try block. So for that I am using the keyword try and giving a column, and going to the next line will take us into the try block. So here we will take two integer inputs from the user. So for taking first integer input, I am creating a new variable a, and here I am writing the print statement or input statement as enter num1. So the first number will be stored in the variable a, and similarly I will be writing the second statement as enter num2, and I will store the second integer in the variable b. So after taking two integer inputs, now we need to store the result of the a by b in some variable. So I am taking the variable as r, and here I am storing the result of a divided by b. So now let's think, what are the errors that can be raised after execution of this program. So let us suppose if the user gives the second integer number as 0, and here b is in denominator, we know that any number divided by 0 is invalid. So for that, zero division error will be raised. So to raise that one, or to mention that zero division error, we will write the except block as except zero division error. So here I am mentioning the column, and in this except block we will write the print statement to make the user understand that zero division error is not possible. So we will write the same statement that 0 cannot be in the denominator to perform division. So this would be one kind of exception that may be raised after executing our primary code. Now let's try to think another exception. So let us suppose if the user gives the string as input. So here, as we have used the typecasting method to convert the given string into an integer and storing the variable a to perform division. So if the user gives string or a sequence of letters as an input, we know that it cannot be changed into an integer, so it may raise the value error. So to do that, or to write that value error, we will be writing another except block by writing value error. So in this block we will be writing the statement that invalid input, like we want only integer inputs or the inputs which can be converted into integers. So if the user gives string input, it is not valid and we need to mention it. So we are mentioning like invalid input for the required operation. So these type of exceptions can be raised, and also there is another keyword like else that we can use. So if both the exceptions are not raised, it means that the primary code is free of exceptions. So the else block will be executed only if both the except blocks are not executed. So here in this else block we will write no exceptions or errors raised. In the next line we will print the result. Here we will write result equal to R. So there is another block which is called as finally. It is in this block we can write any type of statements which we need to print on the screen. It is irrespective whether the exception is raised or not. If the except block is executed or not, it is not an issue. The statements which are in the finally block will be executed directly. So here we will write thank you. So guys, here in this statement the print keyword is not required. Similarly in the next line, so after executing this code we will try to understand the concept by few test cases. So in first case I will be giving the first number as 20 and second number as 5. So here, as you can see, no exception has been raised, so the no exceptions or errors raised, this statement has been printed which is written in the else block, and also the result has been printed, and also thank you has been printed which is written in the finally block. So now let's try to check this code with a test case which consists of any type of exception or error. So first number I will be giving 5 and second number I will give 0, and we know that it is not possible to divide any number with 0. So here, as you can see, 0 cannot be in the denominator. To perform divisions statement has been printed which is written in the except block of 0 division error. So as you can see, one exception has been raised, so the else block part has not been printed, but the thank you statement has been printed because it is written in the finally block. So let us try with the final test case. So in this one we will give the first number as 4 and second number I will give as BS. So as you can see here, invalid input for the required operation, like we know that strings cannot be converted into integers, so it is an invalid input, but ultimately again the thank you has been printed as it is written in the finally block, but the else block has not been executed. So in this way we can use the exception handling concept in our programs. So I hope this video is helpful to understand what is exception handling concept and what are different blocks like try, except, else and finally. So I hope this video is very helpful, and let's meet in our next video. Thank you.